And let's see, Control C, V, V. Let's make a few blank pages, and let's go. All right, so report outline. And so, okay, so we'll just stick with the title of the manual, right? Physics of the cardiovascular system. Okay, so the whole focus about this is going to be about the data analysis, not about blood pressure and EKGs and all that material about what's going on with an EKG. We're going to focus in on taking data and how do we extract the information we want out of it. And it's a nice situation because, again, most people know about blood pressure. They've had their blood pressure taken like 5 million times. And most of us, well, maybe not at your age, but as you get older, you're going to get them, these EKGs. So you may have been with your parents or your grandparents, and you know something about it, especially if you're pre-health. So we report on data analysis techniques. So the wording could get better. I have some cross-outs here, and I had some fits and starts. Applied to two common medical diagnostics or diagnostic tool. Will there be a lab notebook? Just lab day, Layla. So, you should be writing down notes to you. What I want to see is the stream of consciousness. Remember we talked about that last week? So for a lab day, it's mostly, I don't expect a lot of organization. We didn't really have a pre-lab today, so I wouldn't expect to see a title, objective, and what was it, background. But we certainly, I would expect to see this advanced organizer, for example, and just some notes to yourself what these simple words here mean. I'm hoping you fleshed it out a little bit so because remember, the whole idea is that your goal is to be able to keep a logbook that you can pick up next year and understand what you are doing. And and another way to think about it is, let's say you go, wow, I remember back in spring 21, I had this physics lab where we went over data smoothing. Gosh, I want to remember how to do that because I think I could use it for this project I'm working on today. So you want to be able to go back to your logbook and be able to use only your logbook to remind you about how to do it. Now, of course, that level of detail I would only expect to see in a final logbook. But for today, I'd like to see that you're sketching out notes about what went on today, and then maybe you flesh it out later. There's nothing wrong with that. And then, of course, I would think, if I were you, I would be writing down this outline like word for word, right? Even if you do change it some. But, I'm, right? You're welcome. Good. Common medical diagnostic tools, right? Lots of syllables. But feel free to change this if you can think of a better way to express it. Two common diagnostic tools, blood pressure, and electrocardiograms, or electrocardiograms.
So let's see. So this this is kind of outline-ish. So we will study, and I just made a list. You can decide if you're going to make a list or write it into a paragraph. Sampling rate and triggering. Background subtraction. And triggering can come before and after, right? This has to do with characteristic shapes, and in fact, it's part of both blood pressure and EKGs. I didn't make a point of emphasizing it with the EKGs. Characteristics of both. So this is BP and EKGs, just as a nota bene. Important point. Oh, I see. I was characteristic shape. That's what I was seeing. I interrupted myself and I forgot what I was saying, but that's all right. I wanted to say characteristic shape. And it's for both. There we go. So my point too, originally I was saying you could sort of put in here triggering again, because you do it after the background subtraction, right? And then smoothing. And something I don't think I emphasized enough for you guys, smoothing to extract small signals. And what we're doing is we're improving what's called the signal to noise ratio, the S/M ratio. Most of the time, we don't deal with it in the everyday world. You take a voltmeter, you measure a battery, it says 1.5 volts, and everybody goes home happy. But and I'll repeat this in a little while too. If you remember with the EKG was only millivolts, and I may not have emphasized that enough for you, but you'll see it in the improved EKG analysis video. I encourage you to look that over, especially in terms of your final notebook. And that's another thing. I don't know if I made a date. I made a checkpoint notebook. I wanted to see some of that work of the background subtraction stuff. So I don't know if I have. I think I have the final notebook, but the due date might be too soon. I'm going to move it back. Final notebook due date. I'm making myself a note. Oh, you can see that, right? Okay. So make sure, I think it's a really good idea to look at those two new videos, at least skim over them and see any differences. But I tried to make it very clear and closed, instead of some like, well, maybe you should do this, maybe you should do that. I said, do this, do that, one after another in those two videos. I think much more clearly than I did before. Okay, so I think I can go to the next page, but of course you'll yell at me if I go too fast. Let's see, I'll make this bigger. Okay. I'm moving the chat window. I've only come to realize lately that you guys can't see it. Okay. Or at least you can't see mine. Okay. So, background. Oops, I like using a black pen. Excuse me. So we'll start with blood pressure. Okay. So first, we need a few words about basically what systolic and diastolic means. Maybe you have what systolic and diastolic mean, and relate them to heartbeat somehow. And maybe something about how or why they're important numbers. Yeah, so then you introduce the characteristic shape, characteristic shape, and this is where you can copy paste something, and remember that was the something like this. I've never been able to understand that kink. All right. I have to learn more. Something like that, right? And this was the pressure. So pressure is y-axis, and this is time, and then this is p average. And then we would say, what, this is the systolic, right? And I think this is the diastolic. All right, and we use I just saw that little piece of rubber tube, but I showed you the rubber tube. All right, so in principle, you say, in principle, we could just, if we could produce this plot, so, if wishes were fishes, if we could produce this, if we could produce, life would be easy. And then so that you show, then the ideas, I would say, let's see. So we used a cuff and transducer, and similar to standard. However, the bulb, the pump, the pressure bulb, the pump bulb has a steady leak, and we have no control of that. So then you show, picture is worth 1,000 words. So you show and this would be a great place to explain what the units are. And you show a characteristic shape. And then, a characteristic, not shape. I want to stay away. I want to reserve that word. A typical plot, typical plot. And then you point out how the characteristic shape is visible. And then, yeah, I just had an inspiration. So I've shown you how to do a zoom in. So you can expand. Remember, like this would be 0 to something like 10 seconds. So you do a zoom in like 2 to 6. And whatever it takes, like 100 to 150. And then you can show this, but then you can also point out that the transducer has a delta P, and I think it's only about 1 to 2, maybe at most 5 millimeters of mercury. And the systolic minus diastolic is of the order of, let's see, like 50, could be 60, right? Could anywhere be 40 to even 70 or 80, the difference between them, right? So the transducer can't make our life is easy plot. All right, just yell if you want me to go back. Oops. Background. Continued. So we realized we need to extract the characteristic shape and then we have to extract again. Oh, okay. Let's forget that we don't need that extra sub bullet. Characteristic shape and decide where are systolic and diastolic. And that's the triggering part. And I just had a flash when I was writing that. So I'm just going back here for a minute. In the vein of a picture is worth 1,000 words, I don't want a different patience, Harry. I just realized that you could put right here on the characteristic shape, delta P is typically blah blah. And so that really shows it because it has to do with here. Typically 40 to 80, something like that. And then the zoom in here lets you show how, look, here's the pressure here, here's the pressure here, and the delta P transducer is maybe 1 to 5. There we go. I don't think I didn't finish that thought properly. Yeah, this is the essence of physics. It's measurement science. And this is sort of what, when people were first learning about how to measure certain things, this is the challenges they faced, and these are the techniques to extract it. Of course, nowadays we don't really need to do these things, but this, you're getting a feeling for what pioneers had to deal with. All right. Okay. Let's go back to black pen. Let's see what my notes say. All right. So we need extracting. We have to. We have the challenge of data sampling rate. Right, so this is sort of, we could consider this, say, like in an outline form. If this was capital letter A, this would be little 1, little 2. I mean, this is probably capital letter B, C, or D, but just to give you an idea what, how to think of it. We need to extract the so we have the challenge of the data sampling rate, and then a background subtraction. And the background subtraction would typically be a fit to the background. But in our case, and just to remind you, PV equals nRT, we would look to this because the T, in principle, the T could be related to the number of moles. But in this case, it turns out that both pressure and volume are changing. So this means that could not create a physical equation. We went over this because remember, typically a fit function, and the parameters of a fit function represent physical quantities, right? So we, in principle, we have pressure, volume, moles, Rydberg constant, and temperature. So temperature would be held constant, and in principle what we would do is hold the volume constant, but we don't have that ability here. And there could be a way, now there's just really no way to fit because we don't have a predictable behavior of the volume of that cuff. Remember, I might put it aside somewhere, but the cuff is like a balloon. It inflates, but it also changes size. So the volume and pressure both change. So really, the ideal gas law is just not going to work, both mathematically and maybe conceptually. So, since we are only doing the background subtraction, only doing background subtraction, we're allowed to do an interpolation. That's what, we are doing all, let's see, which is, yeah, right. It's like a Venn diagram. A background subtraction is an example. Yeah, a background subtraction, which is an example of an interpolation. And remember, interpolation is just for filling in gaps, for example. Interpolation. So we're trying to fill in what's the background of with these wiggles. We know there's a background, and we want to fill that in. And so this means we're allowed a non-physical equation, and the easiest one is a polynomial. It's just the most useful, and that's the what is it? A to the 0, x to the 0, plus a1 x squared, plus, a1 x1 a2 x squared, plus a to the n x to the n. So this is an nth order polynomial. And you might make a passing notice that the EKG presented similar problems I don't know if it's necessary, but maybe just to remind people you're going to talk about the similar issues to be discussed later. Remember, I'm assuming you guys are going to stop me, right? So make sure if anything confuses you, and if you can do the private chat, nobody will see it, and I'll be careful not to mention your name. And but it's not a stupid question. Even people with PhDs sit out in an audience and are confused by the simplest things. Look at me. It's a sign of confidence at asking what you think are stupid questions are a sign of confidence and maturity, and people who think otherwise are shitheads. So don't be afraid. I'm sorry, Carla. And you know what happens is that if you're a woman, if you're a person of color, it's very much like, look at that idiot. We all know what's really going on, right? And they don't, right? So when you ask the kind of what you think are a dumb question, I promise you're showing them that you're superior to them. If people who disparage that, you're showing your maturity and your thoughtfulness and your superior abilities. I promise you. In my career, what happens is somebody sees me and they see big blonde surfer dude. And it's just really bugged the crap out of me when I first went to graduate school, and people used to treat me like an imbecile, relatively speaking, and I just would really bristle and react, and then I realized, you know what?
these people are like giving me really simple answers to my questions, which is what I want. And I noticed too they were demonstrating their inabilities, that they thought they knew something better than me, and they really didn't. And then the other thing was like building delicate instruments. I used to build ship models when I was a kid and tie in all those tiny knots and things. So they, oh, stay away from that. You're going to break it. And it's like, okay, why should I not break your ass in two? That's another story. All right. Let's just get a little bit more room here to work with. So, all right. So we think that's, yeah, there's my background for the blood pressure. So now this is where, a lot of us get hung up. We don't want to go in, we're going to do procedure, but we don't want to get into, we don't want to be very detailed. Okay, so we took several data rate plots, or we made, I guess, several data sets, with different data rates. And I suppose we have to really, well, of course. And this is where you say, give me a minute. Right, so I think that I missed a trick here. Right, so where is it? Sampling rate, here it is. So we need, and this is real simple. You can just steal, I don't have it in front of me at the moment, but you remember in the manual, there was 2 or 3 plots with some characteristic, some shape, and divided into different sampling rates. You can just steal that picture. In fact, I may have even, like, I haven't streamlined this module. It's been bloating. Yeah, useful diagrams. Let's see. Is it opening? Oh. Useful diagrams. So you might peruse these. No? Well, there's equipment diagrams. But anyways, let's not digress too much. Worst case, you can just copy paste it from the manual itself. So you have to give a little explanation of this. Like, this is all computerized or digital measurements. Are samples, snapshots. So we have to decide on some optimum rate. And for so far, it's really about, and it's not as true nowadays with huge hard drives and things, but it's usually about, let's think about this. We need enough samples to see the shape. And there's this thing called a Nyquist theorem, but we're not going to get into that. To see the shape, but not too many, let's see, to overwhelm the computer, I suppose. We can keep it short because this is not the main thrust of the lab. In fact, it's you or the computer. Even though you're using a spreadsheet, it's us that are it's organic computers. And it's a drag having to work with 5,000 points in Microsoft Excel. So if we can get away with half that data set with a lower sampling rate, we're happy.
Okay, yell at me to go back if necessary. Okay, we took several data sets with different data rates to decide desired sampling rate. So remember, in principle, you've already got all this in your notebooks, right? Because we talked about this 2 weeks ago. Okay, so then we once that was done, we produced let's say working data set, and let's see, there is we produced a working data set at desired rate, which I believe was 50 hertz, but that's later. And then we did some now I don't know if this is the time to talk about the data quality. Yeah, we don't have to go into details. We did a data quality filtering. This was necessary for the polynomial fit. And I don't know if this is the right time to get into it. Let me think. Yeah, I think so. So now you can even you could say, look, typically we would see something like this, and then there might be some crap, and we need the part, only the part with that had with the background, the characteristic background, and of course the characteristic shape. Characteristic. That's it. Yeah, that's enough for now. What happens is, if you don't get rid of this stuff, then the polynomial will try to fit this, and then it'll just go nuts, and you don't want that. You just want this really sweet spot. Okay, working data set, then we plotted data. We used a trend line. And I suppose we said we used, well, trend lines are in Google Sheets too, huh? Trend line to get, let's see, two things we get. So my reason I'm putting it in quotes is that please see, maybe this is a footnote, please see, for example, MS Excel help file. To get, let's see, to determine this is a C, yeah, 1, the order of the polynomial, and seed or start numbers for fitting, final fitting. And D, constructed fit function or fit line, I guess. Yeah, fit line column. Fit line. Yeah, we know what that means. Maybe we have to think about how to say that using the seed numbers, and then we got the residuals and residuals squared. I'm going to wait a moment before I go to the next page. Oh boy. Continued. What did we say? Residuals, and it was F, I think. Right. Then we used solver with sum of the res squared and the fit parameters, the seed numbers to fine tune the fit, and G plotted residuals to decide on triggers. Yep, got it, Samantha. So everybody has to wait for Samantha. And I told you the number one reason, well, okay, there's two important reasons to get a PhD. No time clock and no dress code. And then the single most important reason, I refined this, right? The important reason to become a teacher is to torture young people. And then to be a professor is to not only torture young people, is to actually get your grad students to do all the work, and then you take all the credit for it. Which actually is not exactly true, but it is sort of true. I mean, right now in my research group, the PhDs, we just have no time. We give the kids all the stuff to do, but of course they get to be the lead author and stuff. They get credit. I mean, that's the whole point, right? That's why they're there, to work with us, so that they can build up a reputation. Okay, so let's see. Plotted residuals to decide triggers. Oh yeah, and then H. I don't know how to word this so well. We added appropriate vertical timelines to extract. Oh, and it's Phys and vertical and horizontal lines to extract
or to show, extract slash show the BPs, the BP and heart rate. Okay. So many pages. I was like on a roll this morning. If I typed this, it wouldn't take half this much space. All right, so let's just start on a fresh page because we're at analysis and results. So again, you'll yell at me if you need me to go back. All right, so analysis, results. Okay, so this we've been over, but I'm going to just make sure it's all here. So remember, we had to do I think it was 4 different data rates. First, the 4 data rates, and on an overlay plot, and you have to jazz it up so it's easy to see everything. Yep. Sorry. I went to physical therapy this morning and physically went there. So I got my little lamb here, and I had my blood pressure checked and my temperature. No, my temperature, not my blood pressure. Usually they have us leave them behind. Okay, welcome. Oh golly, isn't it? Yeah, this one is just like a sticker on the green spot, but sometimes the gal, it's mostly been women. And what the hell? Why aren't there any men out here? They make their own little drawings. Like one woman like making little seals or little giraffes. Anyway, usually they have us on the door. There's a poster. It says, "Please leave your sticker behind," because they want to. If you go somewhere else, it's the Keck Hospital, the teaching hospital on San Pablo Street. So I usually just stick it up and leave it there. Anyways, yeah, was treadmilling. I'm getting my ass back in shape after my spinal fusion surgery. Okay, so we have the overlay plots. So you show those. Remember, appropriately pretty, if you will. Excuse me. Appropriately pretty. And then you say, okay, we decided on, and I think it was 50 hertz, but remember, you have to say why. And it's mostly about saying, if compare it to the, and hint, compare it to the characteristic shape. Characteristic shape. Then now we produced. Then let's see. How many blood? There's like four data sets, I think. Of there was me, Dr. H. There's Jenny, and there's Dr. H2. And Christian, my son. Oh, my daughter was just here for a few days. Yeah, you said that. She left yesterday back to Eugene. And then here's a typical one. And
Now here's where you may not have a messy one, but you discuss and you can explain now exactly what the data quality was to cut off any crap beyond the characteristic or the typical, what did we call it? Typical shape, the, okay, we want to use different words. Typical plot, yeah. Yeah. Or the ideal plot, or, yeah, the ideal, because that, so we cut off anything that wasn't part of, oh, of course, it's not the constant leak area. That's it, of course. And that would be when you're pumping it up. And then out here is when the cuff is no longer tight. Of course, easy. So now, there's no way to predict what it's going to do. Oh, cool. That's why it's good that I rewrite this stuff, because this stuff comes to me. So here's our example plot. 62-year-old male. 63. What did I say? 62, huh? 63. Then let's see. Right, so you would also say here's just a sample of the data table. And don't forget there's the fit parameters. Let's see, I should have, hold on. Oh, I'm surprised I don't have it open. I made a video about this as well, though. But whoa, it's this thing. It's hesitating. Yeah, for example, there's a zoom in, right? So there is the vertical and horizontal lines. And then, you just give a sampling of the data. And then the fit parameters, that's the fit parameters. And this is the horizontal and vertical line parameters. It's all in the video if you need a refresher. There's the trend line. There is the legend. Okay. Right. Let's see. Okay. Right. And then for a data set, then you discuss the trend line. And then how does one decide? So it's always about comparing, oops, wrong one. You have the coefficients, right? So there's the whatever order polynomial it is, and you compare that one to the n minus 1. And what you're looking for is that the n minus, the a sub n, the last one, is much smaller than a sub n minus 1. And let's go so you see here that the fourth order coefficient is 10 to the minus 1, 2, 3, 4, and this one is only 10 to the minus 2. So that's 2 orders of magnitude, for example. If I were to go to right, we want to format the trend line. Trend line. Okay, so we want just to be, and it's in the videos, but it's really important to look this over. So when I go to the third order polynomial, well, you might argue that that one's okay, because let's see, that's 3 orders, that's 10 to the minus 3, this is 10 to the minus 1. In fact, I'm beginning to think that we should have gone to a fifth order. But when I do go to the fifth order, and this one unfortunately is doing scientific notation, but this is, oh, that's 10, see, there you go, this is 10 to the minus 3 here, and 10 to the minus 5. So the fifth order might have been the way to go, but I'm not, I'm not going to sweat it. Let's take a look at it again. What happens when we go to 6? And now when we look at 6, now you see there's very little difference between them. So at that point we say, okay, 6 is not worth it. So we look at the various orders, various coefficients until we see that there's no big improvement anymore. And so, for example, you might just show these two. Here's the fifth order polynomial. Here's the fourth order. And, maybe the fifth order was better. Maybe we stopped too soon. This one we like because, again, it was 3 orders or 2 orders of magnitude different. Okay. So then we decided on fourth order. Notice the difference between a sub 4 and a sub 3. Then we hand typed the numbers into this table. Gosh, I forgot to save this. I will often wonder if I don't save it, will the will it be auto-saving? Yeesh, dodged the bullet. CV report, I guess, outline. I'd like to get to some, oh no, it's only 12:15. And we're almost done. Probably should have a better name than that, but that's good enough. Any name for now. Right. Okay, so we decided on a fourth order. And right, so then we So let's see, fourth order, then the parameters, the coefficients, let's see, 4, 3, 2, 1, 0, is that out? Yeah. We then hand copied the coefficients you see in the table. Then we use these parameters for the fit equation, and maybe you show this somehow. And yeah, you can see the red line or whatever. If you look at the legend, you see the fit line, and you see the trend line. So it's, one can imagine some plot where you have little, like, maybe some kind of words with an arrow. This is that. Something like that. Where'd it go? Yeah. Then you see from the table of numbers, we have the time, we have the pressure, we have the fit line, we have the residuals, and we have the residuals squared. And make sure you say, look, this is a to the a4, and in our case, it's time to the fourth, right? That's important. Plus a3 time to the third. And then, of course, residuals, as always, is data minus the fit. And then we have the sigma residual squared. And then, what else? So you have the whole plot, you have the explanation of all the numbers in the tables, and then you show the plot of the residuals. I haven't jazzed this one up yet, but this is the residuals, and you know, it's data minus the fit. But remember, in our case, the fit is the background. And so we decided that this is going to be our systolic when it first starts to, the tube, the blood vessel first starts to open. And then, you know, I've been thinking about what's the best way to decide. And in fact, because I know that the real diastolic is here, I think it asks the way to decide, and it's not, don't worry about it for us. But I think one has to figure out some way to figure out the peak to peak here, peak to peak. And then when it maximizes and then starts to decay, that's actually the place where the diastolic is. We had decided when the lower half starts to get smaller. So we picked, I think, this point. It doesn't matter for us. All you need to do is pick a defensible place. We decided to pick here because at this point, since the blood vessel is no longer closing, the transducer can no longer see that point. Here, since it's got this maximum below 0, that means that the blood vessel is just closing right here, which is the definition of diastolic. That's very defensible. There's no right or wrong answer here, guys. It's all about taking data and saying this is what we did, and this is why. And that's it when it comes to that kind of thing. Because when in the real world, you don't always know the right answer. So let's see. Let's just, so the notes can look better. I want, where is it? I'm looking for my screens snipping tool. Okay. Well, maybe I should have hand drawn it so it's consistent with you guys at home. So you explain where is systolic and diastolic and why. And remember, there's no right or wrong answer. It just has to be defensible. Meaning you can give a reasonable explanation of why you picked it. That's all. This is what happens in real science. Excuse me. And then at the end, the last plot, or yeah, I think maybe it's up to you if you want to just make one plot with everything. Do you want to like say, well, here's the raw data, here's with the trend line, here's with the fit line. Excuse me, that's a lot of work. And then at the end of the day, you have the two horizontal lines and the two vertical lines. And that's, you can watch in the YouTube video, there's a detailed explanation of how to make them and what they represent. So for example, I'm measuring the heart rate here. So I have the two timelines, which I type these numbers in. Then this is the difference, which is an equation. Then 1 over that is the frequency, the beats per second. And then I multiply that by 60 to get the beats per minute. And it turns out in this case, the actual is, where is it? Why don't I have it on this page? Oh, I know I have it. The actual is 72. Huh, wow. The trick is you have to put these two vertical lines in a place where it's the same exact spot. And then you can then go ahead and move it to another one and take a couple of heart rate readings. And let's get rid of this stuff here. In fact, what I'm going to do is I'm going to copy this because it's nice having that zoom in. Copy. Paste. And then we're going to, oh yeah. I just want to zoom it back out. And you just hit these reset buttons. And we got to do the x-axis. Reset, reset. Now, of course, you may want to, like I like it better with this being a max of 200. And this one here, I like it better with a max of 35. That's what I mean about prettying it up, right? And anyway, so you see now the legend has to be moved around. And so that's why you might want to make just a couple of them so you can tweak them up the way you want for whatever you happen to need them for. There we go. But now so what, it's interesting to put your lines in and then compare it to the actual values where the lines go. And it's a way of looking at the character. Well, I don't want you guys to do that. Never mind. That's for next time. I have to refine this lab. Okay. And then at the end, the very final thing for this is some kind of table where, let's see, we have systolic, diastolic, heart rate, and then you have, let's see, from the blood pressure cuff, remember this guy here? So we have cuff and hours, I suppose. And then you have patient 1 and patient 2. And you might maybe put percent difference. And then again, cuff, hours. And then make some comments. And that's that for the blood pressure. I mean, basically, the idea is this isn't the best way in the world. Well, actually, it's a good way to measure heart rate, but it doesn't give the best blood pressure measurements. But you could refine it, it could be refined. But, that's not for you guys to worry about. I'm just waiting a few minutes because you're probably writing more words than are on this page to explain. I guess I'll violate my general rule and I'll make a PDF out of this, right? As soon as possible and post it. But I would still say, please, write as we go. Nothing pleases me more than to see somebody's sloppy notes that are honestly taken as we were doing it in class. I love that. I'm just gonna say my mom is watching me, so I gotta sit up straight, but I just noticed that she had fallen down. So I gotta put her back up here. Alright, I'm gonna get one of my dad too, I guess. They're both up in heaven now. Okay.